Don't think it's, oh, there we go. All right. Okay. All right, come on in. And wow, huge event here again. All right, we're gonna get started. Welcome everybody here in the room in San Francisco in the Google office. Welcome everybody on the live stream. Maybe we can have a shout out for all the people on the live stream right now. Wish you could be here. Wish you could be here also to drink some of this great wine that we have in the back. Definitely, if you haven't tried it yet, check out Grant Eddy Winery. They've got some great free wine to go with your meal and dessert. All right, so how many of you are new members of SFHTML5 tonight? All right, wow. Give it up for the new members. That's a lot. Okay, so we've got a really exciting event for you. You're in for quite a ride now that you're a new member. We have been around for about 4 years. We've had 100+ events. We've grown to, as I mentioned here, over 10,000 members. And we have had 1 million+ views on our recorded content. So one of the things we've made sure from the very start is that we've recorded every single event. And we post those on YouTube, usually within a few days of the event. Sometimes it takes a few weeks, depends on how busy we are. And those views you can find at bit.ly SFHTML5 videos. So definitely check that out. There's a lot of video content from the past. Some of it is still very relevant. Some of it, of course, is a little bit old now. And we, just to give you an idea, we had an event last month about Polymer. And already in just 28 days since that event, we've had over 30,000 views. We've almost had as many views on that content than the entire Facebook F8 conference had in its entirety. So, yes. It was on the same day, that's why it was a good comparison. Really exciting stuff. We've got great speakers out tonight. Every year we run a survey. And in the survey we ask you just a few questions, and so if that comes up, definitely chime in there. One of the questions was, what do you want to hear about? What are the topics that are of interest to you? And one of the big, well, it wasn't a huge surprise for me, but it was kind of stunning how many of you said we want to hear about web security. It was one of the top choices of event talks for 2014. So immediately in January, I went to the one person that I thought could help me with this, which was Parisa Tabriz, our Chrome security princess. And we got together, we went for a walk, planned out this entire event, and here we are finally in May. Now, before we get started, I want to thank a couple of the sponsors without whom it wouldn't be possible to have these events. And a couple of them will come up and say a few things. Before we do, if you tweet about anything tonight, definitely use the WebSec and SFHTML5 hashtags. We've got a bunch of prizes, and some of those will be raffled off to the people that have been active on Twitter. Okay, so maybe a quick shout out to my son, DJ Rocky Lubbers, who's been playing there all night. Great. You can follow him on SoundCloud. And the other thing I wanted to quickly mention, this is almost expired, but you can still get this. It's a Cloud Starter Pack, $500 Cloud Starter Pack that you can just get by going to g.co Cloud Starter Pack. And you can build stuff with App Engine, Compute Engine, BigQuery. All right, the next thing I wanted to quickly tell you about is the two things that we've done in the Scalable Programs team that I'm a part of. We've launched several Udacity training courses. We've partnered up with Udacity to create these great training courses. HTML5 game programming, you may be familiar with. We launched that about a year ago. We have over 100,000 students in that course, and still going very strong. We have about 7,000 people that are active in the course today. So this is over a year after. We've also launched with Chris Wilson a mobile web development course on Udacity, so definitely check that out. Also about 50,000 people already on that course. Another thing that I'm really excited about, and so the team that's been working since about 9 o'clock this morning on getting the live stream up, getting the overflow space all set up, has also been working hard on new video concepts. And so we have a small team in the Scalable Programs team at Google, in the developer relations team, that's working on videos and developer-facing content. And so Cold, that a lot of you will remember from the Udacity course, but he's also spoken here at the performance event. He just released, with the help of the Google Developer Studio team, Compressor Head, and definitely check that out in your spare time. We launched all 3 episodes of it, Netflix style, so you can binge watch Cold talking about compression. It's actually extremely entertaining, so we try to do our best. We really put a high production into it, and I think you'll have a lot of fun, but you'll also learn some really valuable lessons about compression. So definitely check that out, g.co Compressor Head. All right. Then, wanted to hand it off to a couple of our sponsors. and then we'll get started with the show. So, Peter, tell us a little bit about Kazing.
Excellent. Thank you, Peter. Kazing is a company in the South Bay. We have been around for about 5.5 years. We have about 65 employees, and we have a high-performance, very low latency, and very secure WebSocket web communications platform. And we have been a founding sponsor of the San Francisco HTML5 user group, and we are very proud of that. And we have a table out here today, and we brought an interesting experiment here tonight. We took an off-the-shelf drone, and we mounted a handful of sensors onto this quadcopter. And we connected it through a satellite antenna, through a satellite terminal, to the public web. And we communicated the sensor data from that flying quadcopter out to the web, to any web-connected device. And the latency that we have achieved is pretty impressive, and we have videos and all the sensors and all the details here about it right outside the door, so if you're interested in it, please stop by. Also, we are hiring. We are growing very quickly. At this point, we are looking for an awesome product manager. So if this is a technology that you're interested in and you feel the product management kind of attitude, then please come and talk to us, and we can tell you more about the role. Thank you.
Thank you. Hello, I'm Harshit. I'm basically a technical program manager for Salesforce.com in the developer relations team. And I'm here, we're here as a sponsor for this event, and we're really proud of this. I would also like to invite you to come and try our new Salesforce One platform, where you can build the mobile apps on top of the cloud platform. And if you have not tried it ever, just go to the developer.salesforce.com and sign up as a developer free account, and you can start building app from there. The two ways to build it: either you can code or you can use point and click to build the mobile apps, and you can release it right away. If you want more information, we have a desk outside, so please come over there, and we can help you out in setting up the accounts, and we have the instructions over there to get started. I hope you enjoy this event, and also I hope you like to try this new platform and make some cool apps. Thank you so much.
All right, thank you. All right, I wanted to thank just a couple of other top sponsors. Intel, they couldn't be here, but we thank them for their support. Also, Adobe and modern.ie. Thank you for all your support. The slide transitions are very slow here. There. And how many of you went to HTML5 DevConf just last week? Okay, great. So it was another great conference. It was just a one day. They're going to be back in October. I think it's October 21st, but don't quote me on that. Definitely sign up for that. The early bird tickets are usually extremely affordable, in the neighborhood of, I don't know, $69, $99. Great conference. I mean, there are so many tracks going that you can always find something that you're interested in. Really affordable price, and they're going to be in Moscone. So we have room for like 3,000 people there. So it's going to be big. So, oh, sorry. All right. I wanted to hand it off to Leap. Tell us a little bit about what you're doing.
Hello. My name is Edwin with Leap Motion. Our USB device uses 2 wide lens cameras, 3 infrared LEDs to track 26 points in your hand with our V2 beta software. Anyone that wants to test it out, let us know how it's going. Please come by the booth. This is something that we just publicly announced today, so we would love to hear anyone's feedback, whether positive or negative. Again, available to anyone that wants to test it for us. Thank you.
Thank you. Okay. Stephen. PubNub.
Thank you, Peter. Hello, everyone. My name is Stephen Blum. I'm the CTO of PubNub, a global real-time network. We allow you to send and receive JSON messages from anywhere to anywhere using Ruby to Arduino to JavaScript. PubNub is so easy to use. Yesterday, I just got off a Google Hangout with a senator that's using PubNub. Yeah. 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 Thanks, guys. Yeah. Of Washington, state senator. Oh, this is recorded. He knows who it is. All right. Oh, no. Okay. Anyway, we have a free developer program that allows you to send and receive messages forever. So just hit our pricing page and find the hidden link. Cool. Thanks, you guys.
Thanks, Stephen.
Hey, you guys. Hello, everybody. So you probably hear from a lot of recruiters, and I'm one of them. But I work for Matrix in San Francisco. It's matrixresources.com. It's a great group of folks. We have excellent clients, front-end development. It's one of the specialties of our professional services practice. Thanks to Vanessa and Google for hosting. Great group. And really just wanted to say thanks for allowing us to be a participant. And really, matrixresources.com. If we can help you as a candidate or a client, we'd love to have that next conversation with you. Thanks.
Thank you.
Hello, everyone. I'm Iker Jamardo, VP of Engineering from Luday. We have a platform for HTML5 web games and apps developers, and we offer services to be everywhere with those games and apps. From those services, one of the things that we offer is the best acceleration technology out there, both for games and for apps. So we have a booth outside that we are showing some games and some apps, so you can check it out by yourself. How good our performance is. We also offer services to access native features, in-app purchasing, push notifications, social network integration, and to help you make your apps successful everywhere. So as I said, we have a booth out there, and we will be happy if you join us and check out our demos. Thank you very much.
Thank you. Right, I want to thank Bounty Source as well. Very slow. Moboom, tell us.
Hey everyone, my name is James. I'm here with Moboom. We're a CMS platform for designers and developers. We make it super easy to build a responsive website. You can build sites visually, you can customize them as much as you want, and you can code in any language. Stop by our booth tonight. We're offering a free premium site on our platform to everyone here tonight. So stop by and say hi.
All right, thank you. Great. Okay, Sony wasn't here either, but we thank them for their support as well. And one couple of quick final announcements before we get into the show. Colt, myself, Sean Bennett, Don Olmsted, all former speakers at the event. We just published a book about a month ago. It's about HTML5 game insights. It's a sort of intermediate to advanced book with lots of authors. These are just a small sampling of them. Definitely check it out. There's SFHTML5 you can use as a 40% coupon off the ebook. All right, now hopefully all of you have had the chance to get a raffle ticket. We have some great prizes tonight. We have a Chromebook. We've got several bottles of wine, books, including the one I just mentioned, various other goodies. So definitely hang on to those. We're going to have two talks before the break, and then we have about a half-hour break. We come back for two, I believe, quick lightning talks, and then we'll be back again for two more about half-hour talks. We have a quick little final break, and then we have a Q&A with all the speakers to wrap it up. So we've got a really exciting event, and really happy that we're finally here, that it's become a reality. So let me switch to Parisa slides and take it away.
That's good.
That's good, right?
Yeah.
Okay, great.
Let's see. All right, cool. So hello, everyone. Welcome. This is really exciting. I'm very happy to see so many people that are interested in security. So my name's Parisa. Peter, thanks for the awesome introduction. And I get the honor of being the Master of Ceremonies and to kick off our security-themed evening. So we titled this event Web Security, Attack, Defend, and Profit. And myself and the next 3 speakers are going to each touch on those topics. So I work at Google, and some of you may be familiar with our company motto, which is, don't be evil. Well, in the security team, we extend that to don't be evil, but do know evil. And I'm going to use this short intro to talk a little bit about why I think it's really important for developers to occasionally embrace the attacker mindset. So I've worked at Google for a little over 7 years. Currently, I manage the Chrome security team, but when I started at Google, I was an engineer in what we called a hired hacker team. And we had this broad mission of doing whatever we could to improve the security of Google's web applications. At the time, Google was just a web app company. Today, we dabble in other things. So one of the core functions of this team was to do information security consulting, security design, penetration testing. And these are just fancy ways of saying our job was to break the software that all of the other Google engineers were building. We were trying to find holes, ways to exploit the apps that the people building them didn't think was possible or didn't necessarily intend, with the long-term goal of actually finding ways to defend against that. So in particular, we would try to achieve some goal, like theft of information or assets, being able to hijack some account credentials and log into an account we didn't own, because this was the threat we were and still are most worried about at Google. So as a developer, all of you build applications. This is a picture from a prior event. And you all are good people, and you have the purest of intentions. You create useful and delightful applications that make the world and internet a better place. And honestly, you have my admiration, because it is so much harder to build robust and secure applications and software than it is to break them and find holes. So you have my admiration and my gratitude. But the world is not only filled with your kind. And there are bad guys and bad girls that want to break your applications and abuse holes in your software and attack your users for personal profit or gain. And these are the people that I worry about. I worry about them both as a user myself and on behalf of the users of the software projects that I'm involved with. So to pull from my copious knowledge of ancient Chinese military strategy, I'm going to quote a famous general, Sun Tzu, and say, to know your enemy, you must become your enemy. So if my personal experience working in software is worth anything, it's that having experience in breaking software and knowing how to practically exploit software will make you a better developer of secure software. It's one of the strongest foundations you can have. And I know that everybody here wants to build secure software. So take the black hat on and embrace the attacker mindset for a moment. So as I said, to start the night off, I want you to think about breaking the software you use, breaking the software you write. Find the holes, find the weaknesses, and think of ways to exploit it, because I can assure you that if you are working on anything that's successful or interesting, other people will be trying to do that, so you may as well. Only after you've totally tried to break a piece of software can you really have confidence in its robustness and its security. So we have a training for engineers at Google that encourages this attacker mindset. And we often start off with a non-software example. So I want to start us off in the same way. Suppose I tasked you with trying to rip off a vending machine. This vending machine, it's in a large and crowded area. We'll say it's in an airport. And I want you to get out as many snacks as you can for as little cost, and do it without getting caught. So what would you do? Walk up with a key. Where are you getting a key from? Okay, social engineering. I like it. Usually abusing the weakest link, which unfortunately sometimes is the human, is successful. So good answer. What else? Yes, the sledgehammer attack is often effective. I want something a little bit more stealthy. Ooh, let's. I saw one hand. Yeah. How do you turn the machine on? Oh, turn the machine on. Okay. Sure. We'll do. Yeah. Okay. Counterfeit coin. I like. I actually have an image that. This is my favorite attack. If you search online, there is tons of resources on how to hack into vending machines. So there's resources for how to abuse the mechanical components, and you can look up the specific manual for all of these different vending machines. You can find ways to abuse the programming logic, and even the electrical components. So I have not verified any of these. I have no guarantee that squirting salt water in the coin slot of a soda machine will create an electrical current that can result in free soda. I'm kind of doubting that one, but this is the internet, so who knows what to believe. So someone suggested counterfeit coins, and this is actually one of my favorite approaches. Involves currency where there's similar blanks or minting techniques used for multiple different currencies, international currencies. This is a picture of the €2 coin, which is worth approximately $2.70 US dollars. And here are a couple of pictures of coins that have successfully fooled vending machines and are worth vastly less. So we have the Thai baht at about 1/8 of the value, Mexican peso, Philippine peso. There's actually a lot more that have a very similar blank. Coincidentally, I actually was in Germany last week, and I only realized at the end of my trip that someone had actually given me a Thai baht, probably as change at some point during my trip, because I tried paying for a snack, and the cashier gave me this really nasty look and was like, "This is not a €2." So I can attest from firsthand that these attacks, if not successful in a vending machine, at least worked on me. Okay, so to be clear, I'm not advocating that you go and rip off vending machines. Happily, I think we have tons of food if you're hungry, and tons of booze. And apologies to people on the live stream. But thinking through possible ways to attack a system, whether it's a vending machine or a piece of software, will certainly help you build in better defenses to some of those threats and attacks. And that's what I'm encouraging you to do as you build software. So I don't know if anybody in here actually makes vending machines. I assume you care about web applications. So we want to talk about hacking web applications. Has anyone heard of any common types of web security bugs? SQL injection. Anything else? Cross-site scripting. CSRF. What does CSRF stand for? Cross-site request forgery. Awesome. DDoS, distributed denial of service attack. Cool. Any others? SSL is a security thing. Maybe attacks to SSL. Okay, we got lots. I'm hearing lots of things that are right, or technologies that can be abused. So cross-site scripting is one that you're going to hear a couple times tonight. It is the most common type of web vulnerability. It's the most common type of reported vulnerability, security bug today. And I say that with my experience at Google. So it's the most common security bug we find in Google software. It's also the most common bug that's reported or disclosed just across industry today. It's taken over buffer overflows as the most common bug. So the textbook definition, cross-site scripting, it's commonly abbreviated XSS. It's a vulnerability that enables attackers to execute malicious code within the context of a vulnerable web application. So you get, attacker gets remote code execution in a victim session of some web app. So this is the textbook definition. Here are a bunch of headlines that I found really quickly. I cannot think of a single application that I have used that has not been vulnerable at some point to a cross-site scripting bug. This applies to Google software. It applies to lots of other services that I use. And Tim is our next presenter is actually going to give you a little bit more data as to the scope of this problem. But it's a really important bug to understand and to think about when you're building web apps. So I gave you the textbook definition of XSS. And maybe some of you are already familiar with this bug or have actually thought about ways to mitigate it in apps you've run. But the best way to truly understand the damage this vulnerability can cause is really to practice finding them. So just this morning, we actually launched 2 things, which I want to point everybody to. And I encourage you to check out after this event tonight, because they will really help hone your hacking skills. So the first is an interactive guide on XSS. We'll see if links work. They do. So, okay, the URL in the slides, and of course we'll share the slides, will bring you to this nice write-up of cross-site scripting. And you not only get a more comprehensive description of what cross-site scripting is, but really nice interactive demos where you can actually try this out and see how it works in little applications. So you have this fake search engine called Bobazillion, and one of the most common ways that cross-site scripting flaw ends up being introduced into a web application is if the application is handling user input, which is untrusted input, and not actually performing the correct sanitization or escaping before it actually includes this input in the response page. So this first example is actually trying to guide you through finding a cross-site scripting flaw as a user would type input into a search engine. Okay. So check out that. Go learn XSS. And once you learn all about XSS, you can check out this other really fun thing that we launched this morning, which is the XSS War Game. So I'll read off the top. Welcome, recruit. Cross-site scripting bugs are one of the most common and dangerous types of vulnerabilities in web applications. At Google, we know very well how important these bugs are. In fact, Google is so serious about finding and fixing XSS, we are paying mercenaries up to $7,500. So this is true. Tim's going to talk about this again in the next talk, but we reward researchers that report cross-site scripting bugs as well as a bunch of other bugs. And this is a great way to practice finding them. So this is the first level. We'll actually open this as well. And you guys will all help me go through the first level. So cross-site scripting, we talked about them being the most common and dangerous bugs. In this training, you'll learn about this. So if we go to level 1, this level demonstrates a common cause of XSS where user input is directly included in the page without proper escaping. Interact with the vulnerable application window below and find a way to make it execute JavaScript of your choosing. You can take actions inside the vulnerable window or directly edit its URL bar. So your objective for this mission is to inject a script to pop up a JavaScript alert in the frame below. Typically, when, as a security researcher, you're trying to demonstrate, hey, there's a bug, and I'm able to actually execute code, we'll use the alert function because it's just something, a very easy indication that you're able to perform something. So that alert function is a common way to demonstrate a bug. Once you show the alert, you'll be able to advance to the next level. Okay, so this actually looks very similar to the demo that I just showed. We have some user input here, and then we're going to click search. And your goal is to find the alert box. Anybody have a solution? Raise your hand. Yes. Okay. So this, like this. Okay, and then you want me to click search? Okay. Anybody else? I need a hand. Yeah? Okay. Oops. Script alert. You tell me if this looks right. Like this? Oops. Is that what you want? Okay. We have a winner. Okay. Oh, I didn't actually. I could have passed something. We alert undefined. Good job. Okay, so with the help of our friends, I don't know your name, but everybody has passed the first level, and we can advance to the next level. And we're not going to go through all these, but they get increasingly more challenging, and it's a really good way to practice finding XSS and just understanding really how complex these bugs can actually be. It's simple in theory. It's really hard to eradicate them from web apps. So check that out. It's really fun. And we'll go back to this. Once you really master XSS, you can check out this interactive code lab. This is actually a couple years old, but still totally relevant. It's called Gruyere, and it also has cross-site scripting bugs, as well as a bunch of other types of common bugs that you may have heard mentioned by people in the audience before. So there's cross-site request forgery, or CSRF. There is some auth bypass errors in this bug, some mixed content bugs, lots of different common security bugs. And the training will not only describe what the type of vulnerability is, but it will guide you through exercises to find the bugs and also figure out how to fix them. Last book for anybody who can tell me why this is called Gruyere. Yes? Yes, it's a type of cheese, but yeah, in the blue shirt? Pardon me? Yes, so Gruyere is a delicious cheese, and it also is known for having lots of little tiny holes. So I'm probably, I was afraid I was going to get like electronically zapped from going outside the speaker zone. Okay, so check this out. This is going to help as well hone your hacking skill. Those are some excellent resources to start. After that, you should be well suited to start hacking on your own software or the software that you use. And all of this is, have fun with it, but also it's going to help you build better software in terms of defense and potentially even profit, which is what we're going to hear about from our next speaker. So I'm going to leave you with much more qualified hands. My 3 colleagues at Google are going to be speaking tonight, Tim, Eduardo, and Joel. Tim's up first. Tim works at Google, and among many other things, he makes sure that security bugs get fixed, which is actually really hard. It's one thing to find the bugs, it's another thing to get them fixed. So he spends his time working with internal engineers at Google and also external security researchers that find and report bugs to us. And before Google, Tim worked in the Australian Department of Defense. So he has come from faraway lands to join us in the Bay Area. So I'm going to give it up to Tim. Enjoy. Do you want to come?
Yeah.
We can close mine and get rid of this. Oh.
It'll be there somewhere. Come on. Oh, so sensitive. There we go. Just bear with me one moment.
All right, ready to rock. I don't have a stash of books. Let me just say that up front. So I'm going to have to win your attention somehow. Allow me to start with a scenario. So imagine that you and like 2 of your colleagues, maybe 2 people you meet here tonight, you want to get together and you want to form a new startup. So in my case, I actually chose Joel and Eduardo because they're kind of good at what they do. So you're trying to think, what's on trend? I want like the hottest and best thing on the Internet of Things, and I'm going to get so much funding for it, and it's going to be amazing. So as good developers, the first thing you do is you step into dev mode. So you're sitting there, you're just trying to code something out, you're trying to get some form of prototype up and running. And after some extensive user testing, which basically involves asking your friends about what you think is cool, maybe some Twitter magic, you decide on OMG Amazeballs, a beautifully simple HTML5 front-end experience designed to make social media more social. I mean, wow, right? I have no idea what any of that means, but apparently this idea was so crazy, or as the kids would say, totes amazeballs. A venture capital firm immediately provides you with like $60 million of pre-product, pre-revenue funding for 50% ownership of your company, providing that you can get 10,000 users in the first 3 months, and then 500,000 users in the next 6 months. Because that sounds right. That sounds like it's possible, right? Totally legit. So, needless to say, this is the reaction you would expect. Yes, I'm super excited. You and your team are so excited. So you sit there squirreling away, you do some viral marketing, maybe set up some fake accounts, try to get some attention, and before you know it, you hit 10,000 users, which, as we all know, means make it rain. We get our first set of funding. It's going to be amazing, our first payday. Although that being said, I think there's probably an argument to be had with the profit-sharing arrangements. I think I have about $4. Eduardo probably has just north of 10, and Joel at the front, well, come on, I think it speaks for itself. So just as you're closing in on 25,000 users, of course, because that's just easy to do, you notice your user count gets a bit flappy. So it starts going up, starts going down. You can start to get traffic spike and then drop, but your servers are running hot. You don't understand what's going on. There's a lot of traffic going through your servers, but your user count is increasing. So before you can look any further, or before you try to dig into it, unfortunately, because you're the new hotness, this happens. Someone forwards you this article. Newly discovered weakness in OMG Amazeballs reveals user info, causes mass sadness. So it turns out that some nefarious security researcher found and exploited a cross-site scripting vulnerability in OMG Amazeballs. So this was a stored XSS, as Parisa mentioned earlier, or cross-site scripting. I'll refer to it as XSS throughout the talk, which allowed them to insert arbitrary JavaScript into all pages that were shown to the user. So this JavaScript could send copies of all updates made to OMG Amazeballs, including your user data, in-app usernames, passwords, anything that the user could do, this JavaScript could perform on behalf of the user. Oh. Naturally, sadness sets in, but you get to work trying to figure out how this happened. I mean, the money is gone, but as professionals, you're interested in wondering, how did this happen, and what can I do next time differently to make sure I'm not vulnerable to this class of bug? And revenge, maybe. But unfortunately, you look around the site to no avail. So you don't know what's happened. You don't know how the person's exploited the bug. So you're looking around, you're looking in logs. It doesn't really make sense. Then you go to one of the pages of your top users. You go, okay, so who's had the most traffic? And then you see this. Real name. Oh, man, really? So it's, again, you were confident that you were sanitizing data on input and escaping that data on output. But somehow, someone's injected control tags into the page, and just as Parisa highlighted earlier, they're able to load a script. But in this case, they're not popping an alert box. Looks like they're loading something from the user profile directory, so /photos/legit.jpg. You go and look at legit.jpg, it doesn't open. You're like, oh, that's interesting. So you download it, and you download it to your Linux box, and you run file on it, and you notice, oh, this says it's of type text. Oh, that's really strange. And you have a closer look, you open in a text editor, and it's full of nasty JavaScript. So we're owned. It's done. So this little piece of code that runs from the script directory, every time this page was loaded, basically could do anything on behalf of the user and was forwarding that information. Needless to say, none of you want to end up here, but I'm sure you've been here. So believe it or not, cross-site scripting is the most common bug on the internet, the most common security bug on the internet. So I'm here to talk to you tonight about some of the most common bugs that we see reported by external security researchers under the Google Vulnerability Reward Program, and to test out some of your elite hacker skills with some examples later on. And although I lied and I said I didn't have books, I've got Chromecasts, so brace yourself. Before we can get there, we need to have an understanding of how these types of bugs work. So how does it work at Google? So this slide basically covers the range of payments that we make for a single bug of that type to security researchers. So in a non-integrated acquisition, so that's basically a company that Google has purchased, but Google hasn't moved their product onto Google systems yet. So it's some software stack that we've purchased and come along for the ride. That'll score you $100. But all the way up to on accounts.google.com, a typical XSS will score you $7,500. And if you can get remote code execution anywhere on Google, you're looking at about a 20 grand payday. Note that over the period, and you might be wondering, yeah, well, how often does this happen? I mean, really, how much do you pay out? We have paid out over 1.6 million in cash for the web program alone. Other programs at Google, including the Chromium Rewards program, which rewards bugs found in Chrome, and also the Patch Rewards program, which provides money to people who submit patches to popular open source projects that patch security bugs. We've paid out over $3 million to date. As you can see, it's a bit of hard work. We receive over 20,000 reports, and we've only filed about 3,500 bugs based on those reports. So how does it really look? These are the numbers for externally reported bugs in 2013 to Google. As you can see, XSS and XSRF, or CSRF, dominate the field. So these are the bugs I'd like to focus on tonight. We do have other categories, so mixed content, for instance, is when you might have like a page loading over TLS or HTTPS, but you include something over HTTP. So you might be sourcing a script over HTTP. That actually violates the integrity of the page. And in Chrome, you'll actually get a nice little, sometimes you might have seen the padlock with the little yellow triangle on it. That will warn you that there's mixed content running on the page. The other category includes other bugs that Parisa was talking about, like SQL injection, remote code execution, auth bypass. All of those kind of lump into one category because when they're on the slide, you can't really see them. There's also another other category which isn't shown, just for transparency. That includes types of bugs which don't neatly fall into one specific category, like it might be a hybrid type of attack which uses several different types of bugs. And finally, on the side here, info leak. I kind of grade that out, but I think it's important to give that some context. So at Google, we're very conservative when we file these types of bugs. So an example of a bug we might file might say, you can tell that a web server is running the latest version of Apache. Well, you can tell that this web server is running Apache v2.4.9. In and of itself, that might be interesting information for the developer, but if it's the latest version, there are no publicly known exploits. There's not really there's an argument as to whether we should be filing those type of bugs. So that kind of explains why that number is so high, not that we're leaking all over the place. So Parisa spoke about cross-site scripting, or XSS. So what's this kind of less popular sibling, XSRF, and how does it work? Well, that stands for cross-site request forgery, sometimes referred to as CSRF. Eduardo, who's speaking next, is an information security purist, and he finds it very offensive that I use X in XSRF. So I need to point that out to you so you don't mention it in his talk. You'll get very upset. C is for CSRF, X is for XSS. So please take that home with you. What does it do? So it's a class of attacks against applications in which state-changing requests are predictable to attackers. What does that actually mean? It means it allows an attacker to silently perform an action on behalf of the user without their knowledge by piggybacking on top of a session that they already have. So it basically attacks and targets users in authenticated applications. So for Google, that's a problem for us because our users are mostly signed in all of the time. So if we're signed in all of the time, and we expect our users to be signed in all of the time, then this type of attack is very important to us to make sure that we can mitigate against it. So how does it work? The very high level, let's say you were using some blog platform, of course, Chromium, or Chrome, I should say, and you send a request to delete my blog. I'm logged in, please delete my blog. Response, jolly good, blog deleted. Winning. We must be on google.co.uk for this one to actually work. So what's actually happening in the background? Well, your browser sends the request, it has the blog ID in it, it has the site, and it's also sending your cookies across with it as well. So what the browser is doing is every time you make a request to that site, if you have cookies, it will helpfully provide the cookies along with the request. So here, we ask to delete it, and our response is OK. So what happens when someone evil tries to do this? So they're like, yeah, can you delete my blog? Totally my blog. Seriously, it's my blog. The response you'll get is not you, no cookies, no dice, or simply 403 forbidden. The reason this happens is because you don't have those cookies. So if I'm an attacker and I'm trying to impersonate your account, I don't have your cookies, so the browser does not send the cookie along, and therefore I get the response that, no, that doesn't work. So taking that into consideration, how do we actually do an XSRF? Like, how does it actually work, and how do we attack logged-in users to perform a function that silently happens in the background? Well, the first thing we need to do is set up the XSRF. So I'll show you a code snippet later of an example of one. But in this case, you can either set up your own kind of dodgy site and try to get people to come to it, which is a bit more difficult. But what you could do is find a site that allows you to inject HTML into it, or find a site which, if you use some of the tricks Parisa was referring to earlier, you can actually get it to accept HTML that renders in the page as the context of that page. Now, there are well-known cases of people doing this, especially on forum sites or in comment fields. So imagine if you could inject this type of HTML into the comment field of a news site, and then everyone who visited that news site or saw that page is possibly vulnerable to attack. So let's say you set this up, you set up the payload, and you let it run. Let's use the example of the news site. So then what happens is the person requests the site, like they type it in, they hit enter, you get the request for the site, and you get the HTML returned to you. And in this particular set, you have some images to load. So there are some image tags all the way down the page, and it loads it. But one of those image tags is a little bit dodgy. One of those image tags actually says, oh, hey, server over here that's logged in, can you load this image for me? I really need it for this page. And what's actually in that request is I'm asking that logged in server up here to delete the blog. And the request I get back is, OK, blog deleted. So this works because I've enticed someone to visit this site. When the image loads, it's actually not an image at all, and it's sending a request to a server that I'm already authenticated to. And my browser, being the good piece of technology that it is, will send my cookies along with that request automatically because I'm already logged in. So what I'm actually doing is getting this person to initiate a request on my behalf silently in the background. Now that might sound a little hardcore, but that's all it is. So here's my cool site. If you weren't sure, the H1 tag says cool site. I have an amazing GIF, or GIF. We can have that argument over a drink. And then here. Oh, I want to load another image. It's just at here /delete blog. And here's my blog ID. And my style tag says display none. So it's not going to mess up the formatting. It's not going to give me a broken image link. It's going to happen completely seamlessly in the background. And my browser, being the good piece of technology that it is going to load this. This will happen secretly in the background, and then we get thanks for visiting. So that is how an XSRF works. So you might be thinking, how do I defend against this type of attack? Like, how can you stop this from happening? If the browser's going to send the cookies, then do I have any chance? Like, how is the server going to know that it's me sending it, like I'm interacting with the page, versus someone taking advantage of this piece of technology in order to exploit it? Well, the solution is you use what's called tokens, or an XSRF token. Now, a token is just a secret, unguessable, random string which is provided by the server and generated by the server and provided to the client. So you would use this on a state-changing submission or something that's very sensitive. So if you were asking someone to perform a transaction or do a post on a blog, or you are asking someone to change their password, for instance, what you can do is use a token. The server will generate the token, provide it to the client, and go, here's this random string, and when you want to go ahead with this, you reply with the request, and you also send the token along with it. So that way, the server knows that, yes, I received it, and I'm sending it back. So you might be like, well, that might be hard to implement. How do I do that? Well, it's highly likely your favorite framework already has them. Highly likely. And you should listen to Eduardo if you're unfamiliar with this speaking next. He'll talk a lot about frameworks. For those of you who are familiar, and I expect there are some of you in the audience who are very familiar with CSRF-type bugs, please remember to test your fail conditions. So it's very easy to set it up and have it running, and it'd be, you have it running and you've checked it, and it's brilliant. And then you make some seemingly unrelated changes somewhere else along the website, and suddenly the token is not being verified anymore. Or you can replay older tokens from a long time ago. So it's very important that if you are using this, you test your fail conditions. All right. So now that we've covered XSS and XSRF, it's time to see your amazing computer hacking skills in a couple of games of Spot the Bug. So I'm going to give you two examples. These are real bugs that were reported under the Google Vulnerability Reward Program, which received cash payouts. The first one, I would hope most people can spot it. And again, if you really want a Chromecast, then you probably have to be very quick on this one. The second one is not so easy, and I just kind of want to highlight the complexity of some of the bugs that we see. So, who can see a bug in this code? Set is free true. Surely that's not going to work. It works. So this is a bug from 2012, where what actually happened was, this was part of some testing, and this was always validated on the server side. But we made a seemingly unrelated change, and what actually happened was any changes on the client side weren't picked up on the server side. And the server actually just agreed with it and said, yep, well, data is free equals true. So this is an example of just a security configuration. So this is an example of not necessarily a specific type of class of bug, but it's just making sure that you test and understand your code. I'm actually not sure. I think there's also another bug that the person got a free Rihanna song, but that's a whole nother conversation. So in this particular attack, the data is free tag. If it is set to true on the client, it should be ignored on the server. The server should be setting that. So in this particular attack, what actually happened was the server wasn't validating and allowed that to progress. No, just this particular attribute was not being checked. So you couldn't change any of the other things without the server picking up on it. It was just this particular attribute. All right. Now this is the more hardcore one. So to start off, how would you escape this piece of code? What do you need to be careful about especially around the user string? Yeah, so you need to make sure that these bad boys are encoded, right? So the problem is that if I need to encode, I need to escape it, because otherwise somebody could potentially put in another single quote, and then they could put in whatever they want and run to town. So is this all we need to do? Should be okay? Someone can give me a hint why you get one of these. Okay, so you need to HTML escape as well. Why do you need to HTML escape? Why? Doesn't make any sense. You got a book and a Chromecast. Good night for you. Awesome. So, well, it kind of depends. So this is where the complexity of these security bugs comes into play. So fun fact on browser decoding, this is the order that it actually happens in. So HTML decoded first, URL decoding, so you know, like %20 in the URL gets converted from the gets converted back to the space character, and then at the end you get the JavaScript decoding, which is what we showed earlier, like the /x27 for the single quote gets converted back. So how do we how did this particular person, how do we actually get here? So this is it being escaped, right? So what sort of payload would trigger an alert box? Well, it doesn't check for HTML encoding, right? So what if I have an HTML encoded single quote in there? Then when it all gets displayed at the end, I get this. I basically get my alert box to pop. So how did that work in practice for this specific bug reported in the Gmail web? This was actually the mobile interface. It's one of the many mobile interfaces. I'd send an email containing this completely unsuspicious tag that I'm sure everyone would click on. And then the page would render, as you can see. The page renders with just this portion of it, because what Gmail is doing is it's turning that into a mail-to link. So it looks like an email address, and so it's helpfully turning it into a mail-to link. So then when I click on it, I can open a new compose window and type a mail to that person with the email address already pre-populated. What actually happens in the end is this. You can see we've got here, the single quote breaks that, we get our alert box, and then 2 quotes on the end. What does it look like? That's what it looks like. So there's one of our researchers, successfully anonymized, popping an alert box on mail.google.com. I would say so. I mean, I could hopefully make a living on the amount of money that was going out. But yeah, I think there are people who are professional bug bounty reporters, but they usually report to lots of different programs. So I couldn't comment authoritatively on whether they make a living doing it. So if you're feeling a little like this about all the stuff I've kind of spoken about, like this is just crazy, you know, I didn't even understand that last slide. Like, what the hell is going on? Don't despair, because these problems have really cool and easy solutions, believe it or not, and solutions that you can take home with you tonight and start using immediately. Because after the break, these two guys are going to show you how easy it can be to protect yourself from security vulnerabilities in your applications without even having to really understand how they're exploited or write any security-specific HTML5 code. Sound too good to be true? Yeah? Well, I'm actually out of time for questions, so why don't we all grab a drink and aim to be back here just on 8 o'clock. Thanks very much.
So get your mic here. All right, we're going to kick it off with a lightning talk by Kareem. I think it is. Yep. All right, after this, we're going to have 2 talks for about 30 minutes each. We'll take a quick little 15-minute break after that. There's going to be some more wine, some more music, and then Q&A with all the speakers. So save up your questions, and then we'll kick it off with the raffle, and then we'll clear out of here. Are you ready? How many tabs do you have?
Just one. Those have got 2 minutes, so 30 seconds each.
Okay.
So,
all right, go for it.
we are. Crap on you, Java. I'm not screwing with your ass. Fuck. All right, yeah. So the real problem with security problems is not that security is bad or you developers aren't making good things. It's the tool sets and the technologies it's based on do not give you the room to fail. In the time of clouds, where everybody builds stuff that they know, hey, it's going to break a lot and we just need to point to it and throw more machines at it at a cost-effective delta, we don't have that for applications and even some web frameworks. And this approach is actually where things are going. And I'm going to show you a couple of slides, 4 slides, and show you what these elements are. We need the performance to solve the problems of security like companies like Google do and others who are building in this space. I'm going to show you 4 examples. The 4 things we need are this. Everybody and their mother builds an API. And everybody has to deal with memory. If you're using the JVM and you saw the page I was loading, which unfortunately is on blogger.com, which means basically the old Blogger site no longer supports Java. So it doesn't work on this browser, which is Chrome. The problem we have is you don't control the memory, you don't control the VM, you don't control the threads, and you can sometimes control the performance of the app. And what I mean by performance is things like Dart isolates lets you read, load, and kill processes like you do with a Unix server. Things like Berkeley DV, an open source tool, by the way, which Oracle uses to make their times 10 hardware, which is basically an Intel box you can buy for $100. They throw the Berkeley DB on it, put the Oracle controller stuff on it, and charge you $100 grand. The problem with Berkeley DB for them is that people actually find it too fast. At 5 to 10 microseconds rewrites, and people are doing this with WebGL, like our guys at the last HTML5 meeting. They actually built the Sony store after it got hacked so that it runs in 5 to 20 milliseconds, so they actually can fix the rest of the problems later. That's what you need to do with your systems. You need to be able to make your system such that when there's a problem, you control the memory. You're able to break it. My talk on the birth of WebD3 usually loads. I don't know why it isn't on this browser. And then this is what actually guys like our friends at Twitter are doing. By the way, their cloud was based on some stuff that Google built for their clouds. Look up their whole cloud technology. It's an interesting article on Wired. But what they do is they built their own JVM, just like Google did with Dart and Dovlet. And I'm not going to say who I know worked on Dart and the compiler guys before the trial, but you guys can figure it out. There's a reason Oracle didn't get $8 million. And somebody funded their own startup for $16 million, which means he got $200 million. But back to this. when you have a system that can load memory and control memory, you can do real-time processing. You can use tools like HTML5 where you have local storage and local processing and your own socket connections in your browser and your own database and your own storage. It's called user-contributed server architecture. Then you can write apps that are scoped and scripted so that your users contribute the resources you need. You don't have to pay for it, and you don't have to raise $300 million to scale to handle 10 to 100 million users. And that really democratizes. The only key is use fast technologies like Dart and others and BerkeleyDB that let you work in the tens to hundreds of microseconds local. Then you can have the overhead to load like iframes do and actually sandboxes. So you can actually load it like we do with all ads, kill it in an actual sandbox, and your users never see it. Drops the mic.
Thank you. Okay, thank you. Cool. So continuing on, hopefully everyone got a snack. It is my great pleasure to introduce the next speaker, Eduardo. So Eduardo, I have worked with at Google for quite some time. Eduardo reported security bugs to Google, and we decided just to hire him. And now Eduardo leads Google's product security response team, the team is responsible for responding and fixing all of the security bugs that we get, and also preventing them from ever happening again. So I'm going to hand this over to Eduardo. He's going to talk about some of the complexities of security bugs in applications, and then also leave you with some concrete solutions to prevent these in your software.
Can you hear me? You cannot hear me, can you? All right. Oh, now it works. Oh no. Click doesn't work. Oh, there we go. Fancy. Oh, interesting. I want to apologize about something, but I will leave that until the panel. And you can ask me why I'm apologizing now. But anyway. So hello. My name is Eduardo. And I want to start with your help. I know some of you are very introvert and will not want to participate, but just for 1 second, everybody raise your hands. All right. Thank you very much. Everyone, keep it up, keep it up. Only one hand, oh, sorry. Only one hand. Don't cheat. Yeah, thank you. All right. So if you are sure that, let's do the first bug. If you're sure that you can protect against XSS, you know what is XSS, Parisa explained it. Please lower your hand. All right. If you think you can protect against CSRF, you know what's a CSRF. Tim just talked about it. Please lower your hand. No, I mean, only lower it if you know XSS and CSRF. So anyway. All right, anyway. What about mixed content? Lower it if you know about mixed content. OK, what about timing? Timing attacks in web applications? No? OK. Anyone knows about direct object reference bugs, like authorization bypasses, info leaks, and stuff like that? Hash extension bugs? OK, maybe let's do it backwards. Lower your hands. Anyone that knows how to do caching, use caching correctly for security purposes, like not put the wrong caching headers? Come on, one person. All right. Maybe there's someone in the other room, but as well. Yeah, maybe all of. If you are in the other room, no, I'm kidding. Don't do that. Anyway, so web security vulnerabilities are, well, quite a lot. Parisa just did almost the same thing I just did. He was asking like, oh, so tell me security vulnerabilities, and you were coming out with with plenty of them. Anyone didn't know about one of the vulnerabilities that she talked about, or that someone shouted? So every one of you knew all of the vulnerabilities that were mentioned. All right. So knowing how to prevent them, it's actually quite tricky. Not in all cases, it's trivial to know exactly what you have to do. So for XSS, you have to know about escaping, about the right order of escaping. We had talks about there is escaping, there's the right type of escaping, but in the wrong order, and then you introduce a bug. For CSRF, there might be CSRF tokens sent, but then they are not enforced in one case, in like the one case that you need it. There is authentication bypass bugs, and they are just forgotten to add it in one place. Generally speaking, we have noticed, or we reached the conclusion, that even if you want to do things safe, even if you know about the bugs, it's very likely that you will introduce them anyway. We also noticed that even if you don't know, you are likely to introduce them. So it's, if you care about security, if you don't care about security, both ways you're going to introduce, in one case, very complex bugs, in the other case, very simple bugs. Maybe you don't know anything, you will introduce more bugs, but at the end of the day, you're going to have more than enough to have a non-safe web application. So, as Parisa mentioned, I work in the product security team, in the product security response team. And what my team does is, whenever someone finds a bug, like the ones that team Willis just talked about, we go and work with the product team, and we work with them to make sure that it never happens again. So that means make sure that if a bug happened now, we try to look for similar bugs around it. We try to see what is the real root cause, and then we make it so that it doesn't happen. And as we tried to do this in the past couple years, we kind of concluded that we cannot trust humans. So humans are going to make mistakes. And we are all humans, so we all make mistakes. And developers have to be humans, because otherwise we have Terminator and stuff like that. So we came up with this, that what the developer has to know about security to be able to develop secure applications is what is in this slide. And that's, well, in these slides. And that's a white slide. And this is not all my slides, but it's the first slide. So if that's what a web developer has to know for security, then how can they develop secure web applications? How can we have secure web applications? So what we ended up doing is that we are now expecting that every security bug is the framework's fault. That means that if you're using a framework, and the framework doesn't prevent you from introducing XSS bugs, then the framework is not as complete as it should be, and then we should implement something in the framework that prevents the bug from being ever introduced. That's why the talk is called Vulnerabilities Should Not Compile, because it means that we should make possible that a CSRF bug can be launched into production. We should not make possible that an info leak or a directory reference or whatever should be launched into production. What this talk is going to be about is about several ways that we have been doing it in Google, or if we have been not doing it in Google, what we are planning to do in Google to prevent this type of security vulnerabilities. Don't consider that the things that we're going to talk about, that I'm going to talk about, not all of them are feasible for all web applications. So some of the things might not make sense for someone that is developing a game. Some of the things might not make sense for someone that is developing a bank application, for example, someone that has nothing to do with a specific subset of technologies. But still, the general principle is the same, roughly speaking. If I do my job right, then by the end of the talk, you will be able to eat, sleep, and code without having to think about patching a security bug. So you are going to be able to, if someone ever tells you, we have to patch this XSS, we have to patch this whatever, hopefully the first thought that will come to your mind will be, no, that's not how you fix these bugs. All right, let's see if this works. Nope. Oh, it worked. All right. So let's take one step back and figure out why we should even care about this. So why security is important? This is super fast, and I just want to mention it for 2 reasons. So because of your face, because of your reputation is in the line, because if you have a security bug and you are in the news, as Tim just mentioned, then it is your brand, your product, your website, the one that is being talked about. The second reason is your money. So if you are a marketing agency that is making business with another website, with another company, and that company gets hacked because of you, you are not going to get that business anymore. If they talk with each other, they're most likely not going to, you're going to have a bad name in overall. And the most important reason is because it's your responsibility. If you have users, your users trust you. And if your users trust you, you have some responsibility to them to be able to protect them against any type of vulnerability that you are meant to protect them. So I'm going to assume that, and so for that. So I'm going to assume that all of you want to do the right thing. All of you want to know how to do this correctly, that you want to protect the users, and so on. So the right question is, what is the right thing to do? I just told you what I think is the right thing to do, but let's see if that's really the case. So where does this box come from? So that's the right question, right? It's like where these vulnerabilities are coming from. Why do they exist in the first place? And the reason is, or at least the reason that we see, is because as services grow bigger and more complex, and by that I mean at some point you're going to have a website that is moderately successful, that is going to have several users or many users, and eventually you're going to have more people that work on it, and it's not just you, now it's you and other people. Now eventually you're going to be talking with other services and other websites, and eventually those other websites will want to talk to you in like some API, or you're going to be able to use APIs of other sites like, I don't know, Facebook or Twitter or Google Plus or whatever. And eventually, all of these becomes just a huge complex mess. So how do we look at complex systems? Like, I don't know, there is this very popular example of no one really knows where a pencil comes from. Like, it's very simple, but no one knows every single component, where it comes from, the pen, the lead, the eraser, and everything. What about an application like, I don't know, fancy.com? Like, do you guys think that there is one engineer in the company that knows how every single line of code, or that understands all the complexities around it, like the sandbox environments, all the third-party dependencies that they have? Maybe there's someone there is, but it's more likely there isn't. So the way that developers and anyone really can cope with this complexity is that they just simply, or we just simply see it as a simple process. So we just see it like, OK, this is what I expect to happen in this scenario. And we create a very specific set of schemas that or patterns in our brain of how things happen in the general sense. So we will be remembering like, oh yeah, so this probably works in this way, this probably works in this other way. And in some cases it works because the framework makes it work like that. In some other cases it doesn't work like that. So I'm going to go through 5 examples of when the assumptions and the way that you expect things to work don't work quite like that. And that's the reason where, that's the place where security vulnerabilities in most cases come from, when you expect things to work one way and actually they work a different way. So the first one is XSS. We talked about XSS a lot. HTML5, probably the most popular bug that any one of you are going to interact with is XSS. And this is an example of an XSS. So it's hello. This is PHP. I'm sorry about that. And it says hello, and then the variable name. And that's the user. And you as a developer, you as someone that is writing this code, expect that to write the user's name, not HTML. Like, when you wrote this code, or whenever that person wrote this code, they literally did not expect that to be HTML, right? So the right question to ask is, why will it even be HTML? Like, why shouldn't it just be a string? Because that's what you expect, right? It's meant to, like, this syntax is meant to inject variables, not, I mean, it's meant to inject HTML as well, but like, in most cases, it's just going to be used to inject variables. All right, next example, authorization on CSRF. So this is a very simple request of a fake bank application. And the fake bank application, the only thing you want to do, the thing that you want this endpoint to do is like to transfer the amount from to that amount. And if it fails, then you send an error. If it doesn't fail, then you send a success response. So that sounds ideal. That will be the best type of code that you could ever write. It's like super simple, super compact. This post request, the only thing it does is call that API, and that's it. And that's the code that you write. That's the code that you want to write. That's the code that does what you actually want. You don't actually want to know about CSRF and how to generate these tokens and how to authenticate if the user is allowed to do this or that. Like, that's not really what this do post request is meant to do. This is just meant to do this one very simple thing, and you cannot do it like that. Another example, which is very similar to XSS in the source, in the reason where it comes from, is that you want to have a very simple SQL query that says select a star from product where SKU is equal to, and some interpolated string called SKU. And this is short and simple and readable. If anyone looks at the code, they know what this code is supposed to do. Unfortunately, that's vulnerable to SQL injection. Like if you just put a single quote there, you can do whatever you want. But that's short, and that's simple, and that's readable, and that's vulnerable to SQL injection. And you just want to make things work nicely, right? There's two other examples. One of them is authentication. And the case for authentication is a little bit tricky. So you have a login, and the only thing you want is the user to be able to, you just want to authenticate the user. You don't really want to do anything else. You just want to know who the user is. That's your goal when you usually do authentication. And the first thing that comes to mind to most people when they think authentication is a username and a password. That's normal, right? So then you have to deal with account recovery. So you're going to do email or questions, or for enterprises, how an enterprise, how a company is going to recover their corporate account. Like if you have twitter.com/Google, for example, then how is Google going to recover that account? Like you cannot use secret questions because then an ex-employee can recover it. You cannot use an email because then the email can be changed. So how do you deal with those situations? Recovery abuse. So how do you deal with brute forcing? How do you deal with people brute forcing their way into an account? We all know Twitter has this problem that if you have a Twitter one-letter handle, everyone wants to get into that account. Hijacking, how do you deal with someone hijacks the account and then the real user wants to get it back? How do you deal with that? You have to deal with that some way. How do you deal with social engineering your own employees or social engineering the users into getting their account back? How do you deal with password reuse? How many times in the last year password databases have been leaked? So that has been, I don't know, Adobe, LinkedIn, several times. Monitor hijackings. You have to monitor whenever that happens. You're going to make something in there. You have to store your passwords in some strong salted KDF with maybe some key that is stored in HSM, and then you have to deal with performance and making sure that it happens correctly, and that if you lose the key and the HSM has a failure, you are able to recover gracefully without having to depend on the key being in the wrong place. How to deal with password managers. Like if you are going to enforce a minimum password strength, then how are you going to deal with that?
Excuse me, before you go on, I don't really know what was that?
You don't have to. That's the trick. So I know.
What if I want to?
We can follow up offline.
May I talk to you after?
Yeah, sure. So there is more things because I said. Some users might want to know about two-factor authentication. Some people might want to detect suspicious actions and then block the accounts. Some people might want to be able to deal with cross-device authentication, how to deal with a password in a phone and then in a website. Weak passwords, how do you, yeah, I think I mentioned this briefly before. You're going to enforce a minimum strength. If you're going to protect against brute forcing, online brute forcing, putting a CAPTCHA is not going to be enough, of course, because then people that want to get into an account are going to want to have a CAPTCHA. Are you going to put a strength meter? If you're going to put a strength meter, how are you going to measure the strength? And I don't want to continue. There is one more thing, third-party libraries. And this is not all the things that regarding security. These are just 5 things that I happened to choose because this diagram had 5 balls, and I wanted to put 5 things. So for third-party libraries, you have to read all the documentation and looking for all dangerous functionality and unsafe configurations. So if you're going to be using an XML parser, you have to know about XML external entities and about billion laugh attacks and stuff like that. You have to know about if your video player is doing, is downloading codecs, if it's, sorry about that. If your SVG does foreign resolution of objects, and then that allows itself to load another XML file within your SVG file and then load some internal resource in your page. Or DOM.js, for example, that was nice. That some people were using DOM.js, which is an old thing to load scripts from other page, and that ended up causing remote code execution because that's how it works. You also have to monitor CVEs and changelogs and announce lists to be able to know whenever the thing has a security bug. You have to adopt and deploy and fix. You have to, once the server goes out of life, how are you going to deal with that? And if the new versions are not compatible anymore, if they have an API change, what are you going to do? So all of these things seem super complicated, and you just want to do a simple thing. You just wanted to have a website that shows videos to their friends. and then you have to have some video converters, and then you have to deal with authentication, and then XSS and authorization, CSRF, and SQL injection. And how do you deal with that? So what is the right thing? Let's come back. What is the right thing? So the right thing is a Blender. So this is not a framework, before anyone thinks I'm selling you a framework. The reason I mention a Blender is because this is an example of something that all of you know, I hope, and that has something very special about it. So it is a machine that has a motor that turns like super fast and very strongly, about 500 revolutions per second, and has a super sharp light on it, and that can destroy bones and do all sorts of scary things. And somehow we were able to put it in such a form that is relatively safe to use in under reasonable and non-so-reasonable circumstances. So just to share a story, my wife was telling me that she put a spoon inside one of these blenders, and it was OK. And I was like, yeah, that's right. It should be OK. So the Blender has several security mechanisms to prevent them from being a problem, even if they are misused. If there is a warning in the manual that says, do not, under any circumstances, turn the knob 3 times and then press the button 5 times, because in that situation, then the blade is going to go out spinning and hit you in the eye. Like that's not how it works, but except that that's how it works for several web frameworks and platforms. Like, oh yeah, by the way, you shouldn't do this in this way, because if you do it, then that's obviously vulnerable, duh. So yeah, a Blender is meant to be safe against someone that has seen someone use it once and can continue to use it without having to care exactly about how it works. It knows what is dangerous. It knows there's a blade. It knows not to put its hands inside. And if you put your hand inside, I looked online. Most people recover their hands. Anyway, we shouldn't go there. So maybe the right thing to do is to let developers do what they need, and then just fix these problems in the framework themselves. And I'm going to explain very quickly what this means. So for example, for XSS, if a user has a template like this, and user ID is a string, then it needs to be URL sanitized first, and URL escaped, and then HTML escaped. That's obviously right. That's obvious, right? But the framework can know this. The framework knows that the user is about to write something into that specific place. It knows that this one only requires HTML escaping. It knows what to escape in what order in what case. The framework knows. It knows the context. It knows the HTML. So it can just do it, right? In this case, if name is string, it requires HTML escaping. But what if name is allowed to be HTML? How do you deal with that? Well, then you can do something like SFHTML, like a new type that is not just a string. It's a string that has a special meaning and that is special for allowing itself to be rendered as HTML. And the framework can recognize that, oh, this is marked as SFHTML. Let's render it as SFHTML rather than a string. The framework knows that. And a developer that is writing code that is putting this code that it is, OK, this is SFHTML, will be safe. At the worst case scenario, you might end up not escaping something, but then you're going to notice that it's not escaped correctly, and you're going to fix it. You're not going to have a security bug. This case is a little bit more complicated. So Google Analytics, for example, gives you a script tag that you have to put in your website. So this is very similar to what I mentioned before. So if you have to put a specific type of script tag, then the templating system can detect that this is an HTML snippet, and then it's going to inject it like that. And then the developer doesn't really have to think about this, right? They just have to mark the things that are meant to be HTML as HTML, and if they are not HTML, they are going to be rendered safely. So it works. So you can store the safe HTML as safe in databases. You can do whatever you want. You can make sure that your apps are protected against XSS by default. And this works for client-side applications and for server-side applications. Another example is authorization checks. So you have like 4 different endpoints, web endpoints. And you want these web endpoints to all have authorization checks. And what you have to do, usually, not always, but what you usually have to do is you have to put different authorization checks in different places. So where should you put it? Should you put it in here, or here, or here, or all of them, or in the top 4? I think the answer is pretty obvious, that you probably want to put it as close as possible to the data. This is called usually row-level security, row-level authorization. And if you put it this way, it's more likely, it's only one place that you have to do the security. You have to program any security ACL checks. And if you do it right only once, then you're safe. If you do it wrong in any of these 4 places, then you are not safe. These are things frameworks can help you with. Authentication, there are 2 ways of doing authentication. Federated identity, if you trust your users to have one of these 4 accounts, or any of the other ones, using OpenID Connect or whatever. Or you can do your own. Maybe the framework should provide something to allow you to do it by yourself. And they should be able to manage all the questions that I asked before. Or if you don't want to do it yourself, which is a reasonable thing to do, to not do it yourself, then you can just trust one of the federated identity providers to do it for you. Libraries is the last one, and I think it's interesting. So if you have a service that you trusted to take a screenshot of a website, the only thing you want it to do is to go take a screenshot and then give you the data back. However, whenever you load a third-party library, it has this ambient authority of access to everything. So it runs as you. It can read usually all your source code. It can read your keys and connect to your databases. It can do whatever it wants. If you sandbox it, then the only thing it can do is connect through HTTP to this service, get the data in its back, render it, take a screenshot, and then send you back the screenshot as an image. Same thing for decompression functions. The decompression functions don't need access to the internet. It just needs access to one directory. It reads the directory. It reads the compressed file. It outputs it in another directory, and then it gives you back to you. You can even do this for encryption and key management. You can say, like, OK, you have access to this. The only thing you have access to is to this specific key store. Whenever someone accesses the key store, it leaves a log, and then you can decrypt the data. If someone finds a bug in any of these things, then they only get access to one thing, right? They only get access to take more screenshots, whatever. They only get access to decompressing more files, like decompress away. So yeah. Now, bear with me for a second. That's a fun. So imagine that you can write secure code. You can write secure web applications without having to think about security in general, that you trust your framework to do everything for you. Now, you might think that I'm going crazy because there's no framework that does this for you. And you will be kind of right. So what we're doing, and we are doing it starting today, is that I want you, by the end of this talk, to think about the last security bug that you had to deal with. It might be an XSS, it might be a CSRF, it might be whatever. And I want you to send an email to your framework, to whatever framework you use. And I want you to tell them that they should fix it, that they are responsible for fixing it. And if you want to go one step ahead, you can actually write the code that does it, and then send them the code. Or you probably want to discuss with them first and figure out what's the right way. But they might tell you that they have bandwidth, or they might be an open source project that runs on volunteers, in which case you can write the code for them. And if you do that, then Google will give a reward amount from $500 to $10,000 to you and or the framework maintainers if they help you push it to code. So we're announcing this for a couple of web applications. I don't remember the name of all of them, so I had to write them down. So the ones are Angular, Clojure, and Dart, and Git and Go, which are from Google. And then the Django, all the projects from the Dojo Foundation, which are the Dojo Toolkit, Require.js, Grunt, Lodash, Embed.js, etc. Ember, Jinja, Worksec, and Flask, jQuery, Knockout, Struts, and Wicket. And we're happy to add more if you tell me which one I'm missing. Tell me if you want to learn more, just go g.co/security-patch-rewards, and that will give you more information.
It'll have that list. It'll have that list.
It has that list and way more.
Terrific, because I can't write that. I won't remember.
All right.
Thank you.
No problem. So if you do that, you will be able to help yourself to write simple and secure code. You will be able to help millions of other developers to write simple and secure code. And you will make everyone happy, and you will make yourself happy. And to finish this presentation, I just want to say that it works. We did this for Google in a couple of cases, for several types of vulnerabilities, for XSS, for example, and it worked. Some of the products that were in the top vulnerable went to have 0 bugs in a couple years once they finished the migration. And that's it. Thank you very much.
Is it good? Cool. Yes, great presentation. Thank you, Eduardo. Awesome. So now I have the pleasure of introducing our last speaker, Joel Weinberger, Dr. Joel Weinberger. Do you need to set your slides up? Dr. Joel Weinberger. So Joel is a software engineer on the Chrome security team, so we work together. And Joel focuses on usable security, making Chrome security easier for users, and also building features into Chrome to make web developers, to make it easier for web developers to make their applications more secure. So he has a PhD from Berkeley and also worked at Sun prior to Google. And he is going to give you 3 concrete ways that you can improve the security of your web apps. So cool, I'm going to hand it over to Joel.
Thanks, Parisa. Sorry, one moment more. Setup is always the hardest part here. Anyway, so yeah, I'm Joel Weinberger, as Parisa said, and I work on the Chrome security team. I'm a software engineer. I focus on a bunch of different issues. I focus on, but tends to focus on user experience security and tools for developers to help web developers write more secure web applications. And I'm going to talk today about 3 things you can do. So some of the things we've talked today may have made you a little sad, may have made you perhaps even a little depressed about the state of the world, but it turns out that there's a lot of things we can do. And I'm going to talk about 3 that I sort of view as sort of the most important that we can do as a community in making our web applications more secure. So I want to start at a sort of basic question, though, right? We have these web browsers that are running web applications. And a common question I get is, why can't the browser just solve all these problems? So what is it that the browser can do, right? I work on browser security. We work on a lot of issues, and there's a couple concrete things we can do. We can work on web standards, and we can make web standards that are going to be secure and provide secure APIs for all web developers out there. And this is vitally important, and we do it constantly. We're working with all the other browser vendors out there, and you can build lots of secure HTML5 APIs and tools. That's really vitally important. Another thing we do that's also really important is that we actually harden the web browser itself, right? And one example of this is the Chrome sandbox, for example. We harden the browser, so even if the worst possible things imaginable happen, you know, and potentially actual code execution on the machine, we have this sandbox in place to sort of make sure that arbitrary code execution can't happen, and we try to protect the users from that. We also build lots of tools, both for users and developers, to help users have a more secure experience on the web, and try to allow them to understand what's going on. You know, we're constantly testing out new features in web browsers to make sure users know what's going on. But this, of course, raises an incredibly obvious question. What can't we do, right? And the answer is relatively simple, actually, and yet incredibly complex. We can't stop bugs and vulnerabilities in web applications themselves, right? There's nothing we can do in the end if you have a bug in your application, because a bug in your application is indistinguishable from a well-formed application from the browser's perspective. So I want to talk today about some of the ways that, as web developers, you can take advantage of some of the tools that we give you, as well as take advantage of things we can't help you with, and that will make everybody's lives easier, but most importantly, for your users. So we're going to talk about 3 things. We're going to talk about first-class sanitization in your application, and this is actually really playing off of what Eduardo was just talking about, and I think is really important. We're then going to talk about secure communication in your application. And it's something that you may have heard of, you probably have heard about, and I hope you have, but we're going to emphasize why it's incredibly important. And then we're going to talk about security policies for your web application. And sort of the key here is that each of them talks about a slightly different aspect of a web application. So we're going to first talk about sanitization, which is about what happens before your application leaves your server. We're going to talk about communication, which is what happens as it goes across over to the browser. And then finally, we'll talk about what happens once it's actually there. So let's get started and talk about sanitization as a first-class feature. Obviously, we've been talking a lot about cross-site scripting tonight, and for good reason. But let's just do a quick recap here. Really simple example. Imagine you're developing a web form, right? Really simple application. You expect comments in your web form. And you know, it's going to be just sort of simple textual comments, which are going to come from users who are untrusted. Naturally, your nightmare scenario is this, right? A comment ends up on your page, which is just a script tag and is going to execute arbitrarily bad things on the on your web page. So the fundamental problem here, as I sort of alluded to, is that the web browser has no idea what's bad and what's good. From the web browser's perspective, this is all just content coming from the web application. So the real secret here is that you actually have to, figure this out before it reaches the web browser, because the web browser won't know the good from the bad. So this is a really common pattern that I've seen in many web applications. I've even written it for myself at some point, right? You're writing your web application, and as hopefully you got a sense of from Eduardo, perhaps this is not the right approach, but you're going to have some content. It's going to have some user data in it. And so, well, let's just make sure there's no angle brackets in there, right? Because then we can be sure that those script tags aren't going to appear. And indeed, if your user data is a script tag, it's going to take all those angle brackets and replace them, and you'll get that as your output, which, if you'll notice, is just some harmless text, right? That's a little messy looking. You probably don't want that appearing in your web forum, but people, compared to some of the trolling that happens in web forums, that's nothing, right? So we're happy. That's a good day. Let's, another example. Perhaps you're taking URLs and you're going to put them on your web page. So you get some user data, and it's an untrusted user data. You filter out the angle brackets, and you output it to your page, and you're good to. Oh, rats! We missed it, right? In this case, there was no angle bracket because we're talking about some content that's going to appear as a URL, and that's a different context from the original one we were talking about, which was sort of in the PC data area, as it's called, which is sort of the general area that HTML tags appear. And it turns out that, as we've been discussing all night long, this is just so incredibly complex. And if you're going to start writing your own sanitization, as we were sort of doing here by replacing angle brackets, you're really going to have to know a lot of details. And there's been a bunch of academic research on this, and this is sort of an academic model that was developed that explains a lot of the details. And I don't want to get too technical on you, but if you want to roll your own sanitization, you're really going to have to understand that all the relationship between all these transducers and subgrammars, and you got to really understand all these relationships. And no, you're doing it wrong, right? If you ever have to think about something like this in web design, you're totally doing it wrong. You shouldn't ever have to think about the model of the web browser. And so the real answer is that you have to build this into your web flow, right? You have to have this as part of your development as you're going along. And it turns out that most frameworks that you're using today probably have tools that are already available to you, right? And you should be using those tools and be taking full advantage of them and using them to the best of your ability. So, just off the top of my head, there are tools in CodeIgniter and Django and CTemplate. There's the XSS Terminate plugin for Rails. And while none of these cover every case, they're a really good start. And if you're doing any sort of work with these frameworks, you really need to be doing it. And as Eduardo was talking about, if it doesn't exist, you need to get on top of that and make sure that the developers actually build these tools in because they're so important for how this is going to work. So just taking a simple example of, to give an example of how this could work, right? This comes from the GWT SFHTML templates library, which is one of my favorite libraries. It just does a really great job. Full disclosure, it's the Google Web Toolkit library. And basically, if you just take a look at this example, it's building a template which at compile time can sort of determine safely where you're going to be outputting untrusted data into. And in this really simple example, you take the user data, which is eventually going to go into this template, and automagically it knows where this data is going to appear, and it knows the proper sanitization to apply. So when the bad guy actually takes one of these crazy URL-based attacks on you, instead of just replacing the angle brackets, it's going to replace the correct thing. And it's going to know to take out that JavaScript colon and make everything safe, right? And the whole thing here is that you just had to sort of describe the behavior of your web page. You didn't have to think about sanitization. You wanted to just sort of be a part of your workflow. And I think you'll find that once you sort of make it a part of your workflow, it'll make everything you're doing easier. You just won't have to think about it anymore. And the whole point here is that you just make it as easy as possible. It's simple. You're just describing what your web page is going to look like, and everything gets taken care of for you. So that's the first thing you have to do, right? You have to make sure that stuff that comes out of your server and goes to your user will actually be safe. So try to take advantage of the tools that are available to you. But let's talk about what happens when your data actually leaves your web page, right? It goes to the wire. It's ready to go to the web browser and have the user interact with it. So I think most of us have a model of how HTTP communication works, right? Sort of basic web traffic. We have a web browser, and you have a server, and data goes back and forth between the two, and they communicate. Except it turns out that this isn't in any way how it actually works, right? It's actually a giant messy cloud, and it's going through a lot of different things. There's many web servers between you and the other side. There are guys with black hats on who are trying to steal your data. It goes through many types of agencies and things like that, and there's all sorts of other bad and horrible things in between. And the main thing is you have no idea where it's going between the two, right? You have no control over it, and that's sort of actually the beauty of the internet. And so you're worried about these attacks, and you're worried about people sitting in between you and your users, except that one of the more common things I hear when talking to web developers is, yeah, but that's sort of a ridiculous scenario. No one's actually sitting between me and my users. A couple of years ago, there was this great demo that was given that was, calling it a demo is really underselling. It was a great example application of an attack. It was called Firesheep. And what Firesheep did was it was an extension for Firefox, and you could go to anywhere you had access to Wi-Fi, coffee shop, Google Guest, wherever, and you could sit around, you could turn on this extension, and it would just silently record all the data it's seeing, and it would pull out all the authentication tokens and login cookies for all the social networking websites that were flying over in the ether around you. And it gave you this beautiful UI where you could just click on a button and log in as another user and act on their behalf. This could not have been more trivial. You just got a menu of choices of different users that were in that room with you, and you could be whoever you wanted to be, right? And this was a really very real attack, and actually was happening pretty regularly. And of course, once everybody got a handle on it, it was no coffee shop was safe. But then the most common retort I get to this is, but there's nothing sensitive on my site, right? And for many websites, that's true, right? There's a lot of websites that are just news websites, things like that, or whatever. Maybe you're just not that worried about it. And that's fair. People aren't logging in. But let's talk about a different problem you might have. So say you're a website. I use the New York Times regularly, so I always use it in my examples. And you're delivering your page to your user. But as we discussed, you're not actually doing that, right? You're actually going through a lot of guys in the middle. We call this a man-in-the-middle attack. And these people, if you're using HTTP, can be modifying your page however they see fit, right? So in this case, I'm making up this silly example of their adding a script to your page to add ads to your page, which means that when this page actually reaches your user, they're not going to see the ad that you placed there. They're going to see some other ad for some other website that they want to control and appear there, right? And this is, I know it sounds like a sort of silly example, right? Who's adding ads on the fly, right? And that's a fair point. That's a fair point. So I was on Southwest Airlines the other day. This could not have been more perfect. I was on Southwest Airlines, and I was working on this talk. I took a break to read the New York Times. And I wanted to go to the menu of the New York Times, and I wanted to get back to the front page. And for the life of me, I couldn't find the menu. I couldn't figure out what was going on. And after about 2 minutes, I noticed that wonderful Southwest banner ad at the top was not a Southwest banner ad. It was content that was injected by Southwest Airlines. I was on the Southwest Airlines Wi-Fi, and they were putting this content on my page. It had some helpful information about the flight tracker or whatever, but I actually couldn't navigate around the website, right? The New York Times was in no way controlling the content that was appearing on my page. Totally benign, but I sat there for 2 minutes, furious at the New York Times, not realizing that they weren't at fault for this. And so really, I mean, that's sort of the key here, is that this giant banner at the top, in no way part of the New York Times. And integrity is really important to your users. Hopefully it's important to you as well, because you want your users to get the content that you expect to appear on their page. Fortunately, there's an answer. And it's called HTTPS. Many of you are probably familiar with this. It's what gives you that wonderful green lock in many web browsers on many websites. And HTTPS is HTTP plus privacy, integrity, and authentication. And these are all fancy terms that mean that they let the data that you expect get to your user without any of the bad guys in between seeing it. And it does this using a bunch of fancy cryptography primitives and fanciness that nobody cares about. It doesn't matter. What matters is that provides a guarantee of the content getting to your user in a way you expect. And it is just absolutely vital that your websites use this. There's no website that shouldn't have HTTPS. I say that as a very strong statement. If you want to argue that with me, we can talk about it afterwards, but I promise you're wrong. At a very fundamental level, just keep in mind that without HTTPS, you don't control anything on your web page, right? This is like the very most basic point. There's nothing that's getting to your user that is what you expect it to be. So I want to talk about a couple really cool features that are a little more advanced and only badasses need apply. So let's talk about a basic problem with HTTPS, right? You try to go to your page. In this case, let's say it's google.com. And we have this man in the middle, between you and Google. And the man in the middle, he's not going to try to read your traffic because you're over HTTPS. You're Superman. You can't have your traffic be read, right? That's great. So he redirects you, and he says, "Oh, sorry, user. You can't. I actually don't support HTTPS. You should really use HTTP to access google.com, right?" And what happens? Well, you happily say, "Okay, I'll use HTTP because I want to, get to my content." And then you go through the man in the middle, and then you eventually get to the server. But now you're going over HTTP, and the man in the middle can read all your users' traffic, right? This is terrible. And we've lost all the protections that HTTPS gave us. There is a solution. There is a way. And it's called HSTS, which is HTTP Strict Transport Security. And the basic notion is we have an initial connection. Let's assume it gets to the server. And after that initial connection, it returns some content, but it also returns a signal to the web browser that says, you know how you connected to me over HTTPS? You should always connect to me over HTTPS, and you should do that forever. Or, sorry, not forever. You should do it for an extended period of time. The browser takes that information, and it stores it to the side, along with some other important information about its keys and things like that, stuff that you don't need to worry about. And it stores that information for going forward for a time that you specify. And you can do this so trivially. You just have to specify an HTTP header, strict transport security, where you specify a max age for which you want to support this in seconds. And the browsers will hold on to this information. So now when we go back and we have the same attack where the browser, or the man in the middle tries to redirect you, the browser gets that redirect, and it checks against its HSTS list, and it says, nope, sorry, I know that something's going wrong. There's probably an attack against me. And so the browser stops, and you actually get a particularly nasty page in most web browsers that support this that doesn't let you click through or proceed. And this is really important because in these cases, it almost always means there's an attack going on. Almost always. And so this is a really cool thing. You may have noticed that I punted on something slightly, which is that it requires an initial connection to the server. And if the man in the middle is there in the beginning, you're going to have a sad day. But wait, we have a solution for that too. And it's called the STS preload list. And it's currently supported by Chrome and Firefox. And basically, there's a list that comes with your web browser that gives you a list of a bunch of websites that opt into this and say, we want to support STS. And here are the keys that we use. And we expect to always be over HTTPS. And this way, it solves the bootstrapping problem, because the first time you connect, you already know that these websites support STS, and that's how you want the website to operate. As a web developer, it's really quite easy. You just have to contact Chrome. There's a proof of identity kind of thing that goes on, and then your website is actually hard-coded onto the STS list, preload list, and Chrome and Firefox will get that. So this is a really, really important mechanism for preventing these attacks. But even if you just do the strict transport security header, that's a great start. It's a major improvement over the status quo. So the real thing is, you really should be setting up HTTPS today if you haven't. Right? It's the only way to guarantee that your users get the content you expect. There's also this bad rumor that's been going around for years, that HTTPS is difficult to set up and that it's expensive. So if you are a non-commercial website, or I believe actually including personal websites, there are actually several certificate vendors that will actually give you a free certificate. I'm a really cheap guy, and I have a personal website, but I got a free certificate out of it, so I can attest to the fact that this is possible. But there's also varying, if you're a commercial enterprise, there's varying levels of cost. They can be quite cheap. I forget what the numbers run these days. But it's also really easy, and I have some links here to both a website that explains in great detail how to set up HTTPS for your server, as well as best practices to sort of help you avoid making any common errors. So later on, hopefully you'll check that out and do it, because there's just really no reason not to be doing it today. So let's go to the last part here. So far we've talked about making sure that your content is safe as it leaves your server. Then we talked about what happens while it's actually between your server and the browser. But there's one obvious part left. There's what happens once it's in the browser. And that's where we're going to talk about security policies. Particularly, well, let's take a look at this guy here. He looks like a good patriotic American. Looks like he's a sort of a wise man. But he's doing something that is just vitally important from a security perspective. And I want you to look carefully here for a second. I really want to emphasize this. He has belt and suspenders, right? We believe in defense in depth. And I'm a security guy, and I practice what I preach, so I always go belt and suspenders myself, right? It's the only way to be properly secure. It's the only way to guarantee security. But seriously, from a security perspective, we believe in defense in depth, right? You want to have multiple layers of security, and you want to make sure that, sort of the ultimate enemy is cascading failures, right? You want to make sure that if you have any problems, that once you get past that first level, you have something there to defend yourself afterwards. So let's talk about content security policy, which is a relatively new technology. It's been around for a couple of years, but it's really gotten steam of late. And so this is a basic header that you can provide to your website, and it's going to allow you to do some really cool things about telling the browser what content should and should not be allowed on your website. So say you're foobar.com, note HTTPS, foobar.com, of course. I can provide this header today. It's an HTTP header, and it's doing a couple things. The first is this script source thing, which is a whitelist of sources that I expect scripts to come from. Pretty straightforward. In particular, in this example, it expects scripts from self, which is the same origin, so in this case from foobar.com. And it also allows scripts from, you can specify other arbitrary sources as well, in this case, apis.google.com. And what this is basically telling us is, taking this sort of silly web form example from before, if we have some user input, we're obviously expecting something totally benign, but should something somehow make it to our server, which will never happen because we're sanitizing properly in the server, but just imagine it gets through somehow, it's going to actually check to see before it runs this script, is this script on the whitelist? And because it's neither from foobar.com or from apis.google.com, the browser actually stops it. So I fibbed a little bit earlier when I said there's nothing the browser can do in identifying good content from bad content. There is. If the web application tells the browser what good content looks like and what bad content looks like. And content security policy is how you can do this today. So, right, so basically, sort of the fundamental idea here is we have all these bad things happening, and you'll note that even in that silly example, we'll stop that content from appearing, which would make the website look a little funky, but that's okay, because we've taken this evil attack, and we just turned it into a bug. And ultimately, that's a happy place to be in, right? Mistakes happen, things can go wrong, and that's why we want to have this defense in depth. So let's talk about how this actually is working, right? I sort of breezed over it there. the basic idea is that we have this white list of script sources, right? Like I said, in this case, we have self, so the same origin, foobar.com, but also apis.google.com. So when I try to load evil.js, it's coming from some source I don't recognize. We simply don't allow it. There's a couple other things it has to do, though. You might have thought about the fact that we have these inline scripts. And I didn't specify where those are allowed to come from. I mean, indeed, they sort of do come from the same origin, but that's one of the more common attack vectors. So we actually have to stop inline scripts from executing as well. It's a little problematic because, as you might have been able to guess, the do evil script from the browser's perspective is indistinguishable from the my legitimate code script. So we're going to have to stop that one as well. We do have ways of dealing with that. I'm not going to get into that today, but there's some magical things called script hash and script nonce, which actually do allow inline scripts that you want to whitelist to execute. But just know that that's like sort of the minor detail here. There's one more detail. Everybody's favorite friend, eval, right? If that input is something you don't want, of course, that'll execute. So we're going to have to do, from a security guy's perspective, what I've always wanted to do, we're going to ban eval. No more eval. That's great. And these three things combined, for the most part, in most traditional XSS cases, will prevent XSS. There are some corner cases, but for most traditional XSS, it's gone. So even if your sanitization falls apart, you'll have this baseline of security ready to prevent things from attacking you, from attacking your users, excuse me. But there's a bunch of other really cool things going on as well. What I described as script source there sort of works. We have similar directives for style, images, and forms as well. So you can specify a whitelist of the style that you expect to be on your page, for images that you expect to be on your page, all types of content. And this is just to give an example of why this might matter. Poor New York Times again. If an ad comes along and it was expected to load content from one source but switches it at the end, the New York Times would be very sad. And in fact, this has happened a couple of years ago. They actually had a case where an ad switched the content that it was loading before the ad was actually put on the pages. And instead of being a benign ad, I forget what it was supposed to be for, it ended up being one of these giant full-screen, antivirus, fake antivirus attacks. So you really want to make sure the content you expect on your page is what actually will appear. I also want to quickly go over CSP reporting, which I think is one of the coolest features and certainly one of the least talked about. So here we have this policy that is very similar to what we have been talking about the whole time. And basically what's going to happen is that in addition to the script source, we have a report URI. And if we have a violation, so this is a script that's being loaded by an attacker, it'll of course be blocked by our policy because we're not allowing stuff from evil.com to be loaded. It's going to go to the report URI, and it's going to return to your server a big JSON blob of all the information about the failed attack. And we must be doing something right because I said JSON, and everyone loves big data and analyzing lots of JSON blobs. But it's going to give you all this cool information about what was violated, how it was violated, when it was violated, so on and so forth. And I know this sounds kind of trivial, but there's a couple important things here. One, it's always, of course, wonderful to know about what attacks are actually being attempted in the wild. But the more important one is that even if you're afraid of turning on CSP, you're afraid of if you got that whitelist totally correct, there's no reason you can't start reporting immediately, right? You can go into a report-only mode where you don't actually enforce the directives, but you just have the reporting happen. And you can use that to learn about what sorts of attacks are actually happening. And Netflix has actually done this on some of their sites, some of their, I forget exactly which sites, but some of their sites they run. Netflix has actually turned on CSP in report mode to find out what's actually been going on in the wild. And they actually found a whole host of attacks that were going on against them. They filtered out the benign stuff, and they actually found real attacks. And so, even just by being in reporting mode, they were able to stop real attacks on their users. This is just the tip of the iceberg. There's just a huge amount of more that goes on with CSP. CSP has been growing a lot. There's frame busting prevention. There's you can sandbox iframes using CSP. We have some really cool stuff that's in the standards bodies right now about guaranteeing the integrity of resources that you're loading. And also we're working on some stuff about sub-origins and having more fine-grained origins. So I highly encourage you to check out more about CSP. And this is sort of the key line, right? You can turn on CSP today with this one tiny HTTP header. Now, for many sites, it'll have to be more complicated depending on what you're loading. But I highly encourage you to, at the very least, look at report-only mode so you can see what's going on in the wild today. On HTML5rocks.com, there's some great tutorials on content security policy. It's a great site for other reasons, too. But again, CSP, super easy to use. And once it's on and once you have a policy, you shouldn't really have to think about it very often, if ever. Right? It's all about easy. Perhaps you've seen that as a theme in this talk. But security doesn't have to be hard. It can be just a part of your workflow. So as just as a last thought, I encourage you to go out, just look at your tools that you have in your workflow today. Think about how you actually are preventing security today. And if you're not doing everything that you possibly can for your users, at least go out and try these three. At least try to get these three started. But thank you so much for being here today, and I will be around for questions later.
All right, thank you. All right, we're going to have a quick 15-minute break while we change the room into like panel-style Q&A setup. If you have questions, just come back and we'll have a mic set up for you. So enjoy the 15-minute break, come back, and then we'll have the Q&A and the raffle. All right. Great. Welcome back, everybody. We're still waiting for one of our speakers. But if you have a question, come up to this mic and fire away. I know there's some hot questions. Oh, actually...
Should I wait?
Just wait 1 second. I wanted to give all the speakers our traditional SFHTML5 speaker gift. Da-da-da. What? Here, hold that up. These are original prints that we commissioned for the user group from a real painting. Give it up for the speakers. Let's hold it up. Ah. All right. Okay, with that. All right, we've got some burning questions right there. Let's do it.
Hello. So next Tuesday, there is going to be a hearing between the Justice Department and the EFF on whether or not courts can request user data from companies. That, in response, has created a lot of talk about client-side crypto, and there's a working group in the HTML5 about Web Crypto API. I was wondering if you guys had any sort of opinions on Web Crypto API and whether or not that was a viable response to that kind of attack. I know that Proton Mail just released their beta a week and a half ago, and I was wondering, since that is so slow currently because it's JavaScript crypto, whether or not Web Crypto API would contribute to that at all.
So no, I think Web Crypto is super useful. Generally speaking, it has problems in the sense that it's a native crypto library. So it's likely that people that want to implement their own crypto are going to fail at doing that. But if they use a crypto system that is well known, it's most likely that it's going to be safe. I'm not sure if I answered the question because it seemed like it was whether Web Crypto was cool. I like it.
Hi, my name is Suyash. My question is more general. It's related to the whole philosophy we learned today about how important security is and to submit security vulnerabilities and report the bugs. I'm wondering, like, Google has this program where they offer, rewards. What about, like, because if in the application there exists like a vulnerability and it's happening for Google, possibly it's happening for other large corporations. Maybe some of those who don't have a bounty program, like how can we as like, good citizens, I guess, report something and not like go to jail for that?
So to answer your question about can you submit bugs to other programs? Yes, you can. There are actually programs which are set up like the Internet Bug Bounty, which is a program which allows you to submit bugs in products that might not have a vulnerability reward program. And they will actually sponsor some of those payments as well. So it's possible for you to submit a bug through a program like that, and then you will also receive a payment for that. That being said, though, with the wider issue, I think that with the vulnerability reward program that we run and the different types of vulnerability reward programs we run, you'll probably see that we will continue to invest in that. And we'll probably end up looking at some more client-side applications in the near future.
So if some company doesn't have a reward system, you can, like some other website, where do you go for that, you said?
So one example of that, there are companies which will conglomerate bug reporting for you and take care of the relationship between the company and the disclosure and keep you at an arm's distance. One example of that is the Internet Bug Bounty. Okay. There are other examples. I think Bug Crowd is another one that comes to mind. But you can always, usually security for the big companies is a good place to start. And if you present yourself in the right light, I can't imagine you're going to run into many problems.
And can you just blog about it if you find something on your own?
Well, that's a personal decision. I mean, there's the debate between full disclosure, coordinated disclosure, responsible disclosure, whatever you want to call it. I mean, it's really up to you how you want to handle that situation. That being said, there usually are avenues that companies will be willing to accept those type of bugs.
Okay, thanks.
Yeah, one company just got funded for $9 million to help solve that problem today, TechCrunch. What do you see as fundamental computing security problems? I mean, if you have the whole arms race back and forth, what are some things that are fundamentally technology, structure, approaches, or even language, syntax, or architecture in clouds are problems that fundamentally are bigger than what one company can fix that people should be looking at, like OpenStack's doing and other stuff?
They were just a lot of scary words to me. I mean, to be honest, I think at the moment at Google we're focusing on the products that we build and how we can do that. Unless someone else has comments specifically on the wider issue, I'll hand over to Joel.
I mean, I think fundamentally, we'll always have bad guys who are trying to break whatever we build. So in some sense, it'll always be an arms race. But that doesn't mean we're losing. And in fact, from my perspective, we've done a pretty good job over the last 10 years. If you compare web security and the tools available to us from 10, 15 years ago, I mean, it's just a world of difference. And even if you compare, web application security more generally to traditional application security and OS level security, we've done some pretty amazing things with the fact that one website can't mess with another website. Like that's a pretty big fundamental win. So I do think there'll always be an arms race. I'm not sure we can really avoid that. Maybe there's somebody who's got a great idea how to fix that. But I think there are leaps and bounds we take. And I actually think we're doing a pretty good job in web security. So yeah.
Why is it that when we used to have secure computing and projects and other frameworks, the actual break-ins we have now cascade because it's so independent? Like we don't have tools to keep that from happening with layered security. We have hits that are now 200 million users, or OpenOAuth, or SSL, or these are the things where the tools we all use now affect everybody in one hit, like Heartbeat hits everybody. That didn't used to happen as much, even though the tools were easy to build with.
I mean, I'm not...
That's a statement in question, though, because actually it's getting harder to secure larger surface areas.
Maybe. I mean... A Windows bug was always pretty darn bad when it affected 95% of everybody. Worms in the early 2000s instantaneously affected most of the world. So I'm not actually sure that's a true statement. There are certainly problems. I mean, those are all valid issues. And I think it's an open question how we're going to address that, and I think it's a great question.
So just to mention on that, one thing that might be worth mentioning is that the way that DNS works in general is that they try to diversify as much as possible implementations and operating systems and so on, just so that if there is a vulnerability in one system, it doesn't bring down the whole internet. And maybe keeping up on that idea might be worth, but they have other problems that are unrelated anyway.
Okay, so this is mainly based toward Eduardo and your talk. And my concern, or really my question to you, or how do you think this should be solved, is when you put the responsibility to security to somebody else, I mean, in your case, it's you or you at Google or whoever at some company or some other developer submitting patches, if you put it all out of your own control, what stops those other patches or a bad patch to be put into a large system? For example, a very recent famous example is, let's say, the Heartbleed bug. Yeah, everybody's relying on this SSL, or everybody's relying on one specific source. If what securities or safeguards you have against, let's say, a company who doesn't, oh, it's a patch, hey, it looks like it works and it fixes, but it's actually, let's say, an evil patch. and the company mistakenly accepts that and now puts everybody in danger, what safeguards do you foresee that will prevent those kind of things?
So it's very similar to what I just mentioned right now, but like one of the reasons that we're not just sponsoring one framework, for example, is because we want to make sure that that people have options. So for example, in one case, if there are several frameworks that have roughly the same qualities or values and people can choose and compete between them, like you can choose which one we want to use, then you're most likely only half of, if there are 2, then half of the internet will be broken. If there are 20, then 1/20 of the internet will be broken. And that's the problem with like all software. Like if there is a common component, if anyone trusts it, and it's going to affect a lot of people. One other thing that I mentioned at the end, which might not make sense for OpenSSL, for example, as you mentioned with Heartbleed, but it makes sense for other common components like FFmpeg or things like that, which is sandboxing. So if you sandbox things that have very specific set of constraints that only need to do a specific subset of job, then vulnerabilities in that system are not going to have as big of an impact as they will have otherwise.
Okay, good. And then just on the one point query on that, the sandbox itself, would that be in any way vulnerable to, say, somebody bugging the sandboxing or making it not sandbox? Is that possible?
That will be a feature of the operating system or of the platform. So for example, in BSD, you have like just chroot jails, or like in Linux, you will have like the seccomp or like whatever sandbox. Windows has their own, Mac OS has their own. In the web framework, we have appropriately named iframe sandboxes and CSP that can be somewhat used for sandboxing as well. So it's a feature of the framework. If the browser is broken, then the internet is broken as well. But like then you have several browsers, hopefully. I mean, if there is, as long as there is no complete diversification, there will always be some sort of one thing that can break the internet. OpenSSL is a great example, but there is also NSS, for example, and like many people didn't break because they didn't use OpenSSL, they use NSS. And that doesn't mean that NSS is not vulnerable. Maybe NSS is vulnerable to even something worse, but then people that use OpenSSL will not be vulnerable. That's the problem with common components.
I just want to say one thing is one of the fundamental security design principles is defense in depth, right? So at any point, like if your software is dependent, like the total security is dependent on one bug, then that is something to worry about. And that's why you want multiple layers of defense. As developers, we rely on abstraction. Like you will not be able to understand firsthand every single layer of the software you're trying to build. Otherwise, you just can't get anything done. So like you're right that when you are abstracting or dependent on somebody else to actually supply code and behave as you expect it to, there is some risk in that there may be a bug there, if not today, then in the future, which is why it's so important to architect your software such that you actually do have, you're not just relying on kind of dependent on one bug.
All right, thanks very much.
Hi, thanks for doing this. Question about testing. Are there any automated ways to test for something that's very common like CSRF? If 75% of what you're seeing is CSRF out there, are there any frameworks or third-party services that you can use? And if not, are there any challenges to developing such a service?
So for CSRF in specific, I think it mostly depends. Like if you're using, this is HTML5. So in this case, you might not use the traditional model of just having a form and then the form submitting things automatically, which means that traditional scanners, there are scanners that find CSRF, but they might not find them on very client-side rich applications. I think at the end of the day, in this case, you need to either depend on the framework to do it safely, or if you want to really do it by testing, then you need to either do something specific to your framework or use a tool. There is one tool called rat proxy, for example, that one of my colleagues released, which analyzes requests passively. So you put it as a proxy, and then it makes requests, and then it analyzes the requests, and then in some cases it repeats requests that it thinks are state changing without the CSRF token and my find box. But it's not foolproof, of course. With testing, you mostly are trying to find these bugs, but you're not sure that they are not going to happen. That might help. Anyone else?
Thank you for this nice presentation. My question is, if HTTP is very vulnerable protocol, why not get rid of it or disallow it?
Oh, you're my best friend. Oh, you're my best friend. I would love to do that. No, I mean, the answer is, as a security guy, my goal is not to break the world, right? As much as I'd like to sometimes, it's really important that the world keep working. And while it would be great to live in a world in which we only have HTTPS, that's a world we're working towards. And so, I mean, there are things we do to encourage people to go to HTTPS, right? Like, we have these green locks, right, which look really nice and are really pretty, and they actually make your website look better, and that's great. And there's a reason we do that, right? And we want users to know that they're secure, and when they're not over HTTPS, we want them to not have that feeling of security because they shouldn't. But anytime if you were to just if any of the browsers, for example, were to just take away HTTP, nobody would use that web browser, or at least a very small number would. Well, no, because the users would know, and users would know because they wouldn't be able to get to the New York Times, for example. Just as a random example. So our job as security, as software engineers who focus on security, or as security engineers, is to make the world a place where HTTPS is a place you want to be as web developers, where you want to be as users. And if we're not doing that, then we've done something wrong. So we're trying really hard to get there, and we're trying harder and harder, and we're trying to move towards that. But it's not something we can just jump into tomorrow, as much as I'd like to. Although there are ways you can do that. I mean, you can get extensions for Firefox or Chrome which won't let you visit non-HTTP pages or non-HTTPS pages, and I do recommend that.
Yeah, but one more comment is for non-developer or technology expert, they don't even distinguish between HTTP and HTTPS. And one of my friends asked me, Google Plus sent me email that my account hacked because I asked her what type of password you have. She said, "Let me in." So I told her, no, that's not the password you want. You want to have capital letter and at least one capital letter, one digit, and one special character, and at least 8, blah blah blah. But
well, I'm going to focus on focusing on the HTTPS and users not knowing what that is and so on and so forth. And that's a totally valid point. And moreover, I would make a stronger statement, which is, we don't even necessarily want users to know what HTTPS is. We want them to know secure versus insecure, but we don't want them to know, what is HTTP even. And so, well, the claim is that users don't even know secure from insecure, and that's possible too. So there's two answers. One is that we actually do find differences depending on, for example, the user interfaces that we have. We do find differences in how users interact with web pages. So one answer is that, as a browser vendor in particular, we try to find ways of expressing or encouraging users to use more secure web applications through our user interface design. The other answer is, through the same tools, we also want to encourage web developers to choose HTTPS because that's ultimately how we're going to solve this problem. And so we try to come up with ways of making sure that our developers have HTTPS as the better option for them, and that's something they'll want to choose, and to make it easier. Part of that's outreach, right? There's not a coincidence we're all here tonight trying to discuss these issues. But others is sort of implementation as well. But the really short answer is it's really, really tough. It's really hard to make this happen. But we're trying.
Thank you.
And you guys can all help, yeah. Make your website secure, first of all, and tell all your friends, and so on and so forth.
So just one more thing on that last thing. There are some features of HTML5 that are being released only for HTTPS sites. So that also works as a carrot to help.
What about HTTP 2.0? It's already here. Does it support any security related? Has any security related fixes, or I don't know?
So I'm actually not sure if I'm not sure who won not won, but who ended up on top. But like Speedy, for example, Chrome only supports Speedy over SSL, even though it could support it over HTTP, like over non-encrypted channels. And that was it's similar, right? It's just like a carrot. But I think Speedy is possible to run without SSL. It's just Chrome doesn't implement it that way for, I mean, security and blah blah blah.
Still.
And the debate is still being had, yeah. But that is the current implementation and how it has been implemented.
My main question was, it's more philosophical. Like, today I learned a lot about security and I kind of underestimated it. And I know a lot of companies do. They don't have a dedicated security person until something bad happens. Who should be the one who should be an expert or know how to write correctly or write better code that has security checks and balances? Should it be developers or should it fall under QA? Who should be testing for these kind of attacks? And
so I think it should be the framework developers, and you should just choose the right frameworks. But if you want to go the way of teaching all the developers, then it shall be all the developers and all the QA testers and everyone, because all of them are humans. And
I can just say one thing for at Google, it is the responsibility of everybody who's working on a product to care about security, just as similar as to care about the usability and in general the quality of the product. Security is just one aspect of the quality of the software, and I don't think you can actually delegate the responsibility to any single job role. So all software engineers are responsible for security, all product managers, all program managers. We have people that work in PR and legal, and they need to care about security too. So I really don't think it's something that you can delegate to one person, because it's a quality of software that everybody needs to care about. And that's how we make it scale and work across lots of software in a really big company.
Cool. Last question for Eduardo. You said ask me in the question, why was I sorry about? What is that?
Because I use Prezi, and Prezi is a Flash application, and I use it in an HTML5. That's why I said sorry.
Okay, last question. On June 5th, there is a project called Reset the Net that is asking web developers to do one thing to improve web security. I was wondering if I could get an answer from each of the panel on, obviously, your answer is HTTPS. What are the other three panelists' opinions on what is the one thing that you could do to improve web security? And part of this movement is to, whenever you do that thing on June 5th, write about it. Like publish it, Twitter it, or tweet it, do anything you can to talk about web security.
I'm pretty sad you didn't give me a chance to answer that. But yeah, HTTPS, yes.
I talked about framework security and blah, blah, blah. So just make a patch or talk to send an email to your favorite framework and tell them about what you want them to do, or do it yourself after talking with them.
So I'm also SSL evangelist, but since you're already going to do these things, and you have to go last. I guess mine would be, if you're going to use existing frameworks or components or whatever, make sure they're updated. A lot of the times vulnerabilities are disclosed, so people know about the bugs and how to exploit them, but you actually don't get the fixes unless you update your software. So use SSL, use existing frameworks, and make sure it's all updated.
Don't worry, I'm used to going last. My last name is Willis, so I was always last until the kids whose last name started with A complained, and they're like, all right, for this really annoying task, we'll go reverse alphabetical order. Willis, you're up. For me, it would be, so if you can't sell them on HTTPS and you can't sell them on the frameworks, send them the XSS war game. Please, please, XSS is a huge problem. And the one thing I would do is, if you can't sell them on the frameworks and you can't sell them on HTTPS, please use the links we provided tonight and get them educated and interested in XSS. Because if we could squash that, we would be in an amazing position.
Yes. Yep. Just go for it. Yep. It's always fine. Thank you. Spread the word. All right. Big round of applause for all the speakers. we are going to have the raffle now, and we're going to sign off on the live stream. Everyone, hundreds of people on the live stream, thanks for joining us. We are going to go through the raffle tickets. Actually, first off, raffle or prizes for